Salam and welcome everyone. So today we're going to be working on the question on the screen that says when 178 joules of energy is supplied as heat at constant pressure to 1.90 mole of gas molecules, the temperature of the sample increases by 1.78 kelvins. Calculate the molar heat capacities of the gas at constant pressure and constant volume. So the first thing you note is we're going to reread the question and jot things down. So we're told that when 178 joules of energy is supplied as heat, so this means that Q equals 178 joules at constant pressure. So Q sub P, since it's constant pressure, to 1.9 mole of gas molecules. So the number of moles is 1.9 mole. The temperature of the sample is increased or increases by 1.78 Kelvin. So change in temperature equals 1.78 kelvins. Calculate the molar heat capacity of the gas at constant pressure. So that would be Cp, comma m, okay, and then Cv, comma m, and we're asked to calculate the molar heat capacity of the gas at constant pressure and constant volume. So Cp, comma m is the molar heat capacity at constant pressure, and Cv, comma n is m is the molar heat capacity at constant volume. So the first thing you need to know is because we're given what the heat is at constant pressure, like at the beginning of the first like sentence, you would actually use this information to you are going to use the information to be able to determine the formula that we're supposed to use. So Q heat at constant pressure is actually equal to the number of moles times the molar heat capacity at constant pressure times the change in temperature. So from this, we can determine what the molar heat capacity is at constant pressure. So CPM equals, we're going to put this equation up top here in terms of Cp, comma m. So that's going to be Q or QP divided by number of moles times change in temperature. So this is how you solve for the molar heat capacity at constant pressure. We already thankfully have the heat at constant pressure to be 178. We have the number of moles and we have the change in temperature. So all we have to do now is just simply substitute. So you have Cp, comma m equals the heat is actually 178 joules. So that would be 178 joules divided by the number of moles. So that's 1.9 mole times change in temperature will be 1.78 kelvins. So when you have all of this information, you end up having 52.6316 52.6316 joule per mole Kelvin. So yeah, remember now that whenever you're dealing with chemistry, you're supposed to like round up and you're supposed to look at the sig figs that you're given and you're supposed to basically approximate to the sig figs that you're given. So, or to the lowest sig figs that you're given. So in our question, we have 3 sig figs for heat, we have 2 sig figs for number of moles. So we're gonna approximate whatever our answer is to 2 sig figs. So Cp, comma m ends up being Cp, comma m ends up being 53 joule per mole Kelvin. So this is basically the answer to this question. So to find Cv, comma m, there's a formula that we're supposed to use, right? We have this. Now the formula does not come in molar heat capacity, but instead it just comes at heat capacity. So the formula is Cp minus Cv equals Nr, where Cp here is the heat capacity at constant pressure, okay. Cv is the heat capacity at constant volume. So yeah, that's basically it. The next thing you have to do is for you to determine how do you go from heat capacity to molar heat capacity. So for you to go from Cp, comma m to for you to go from Cp to Cp, comma m, and for you to go to from Cv to Cv, comma m, all you have to do it is Cp divided by number of moles equals Cp, comma m, as well as Cv divided by number of moles is equal to Cv, comma m. So the molar heat capacity at constant pressure is equal to the heat capacity divided by the number of moles, and the molar heat capacity at constant volume is equal to the heat capacity divided by the number of moles. So that's it. So CVM is equal to the heat capacity divided by number of moles. So that's how you do it. So from this information now, we can go on to solve this question. Since we're just giving heat capacity, what this is telling us is that we can just divide all of this information, because whatever you do on the left side, you have to do on the right side. You divide it by the number of moles. So you divide it, and of course you divide number of moles here, number of moles. So what you end up with is Cp comma m minus Cv comma m equals R. So this is it. Now we've already determined what CPM is. We know what R is. R is just the regular gas constant. So that's 8.3145 joules per mole Kelvin. So Cv comma m, you just rewrite in the equation. What you actually have is Cv comma m equals Cp comma m minus R. So now we know what Cp comma m is. We just solve for it. We know what R is. We have that to be a constant. So Cv comma m equals Cp comma m is actually 53 joules per mole Kelvin. But in chemistry, when you are using an information to do further calculation, you have to leave it in the actual value, not the approximate value. So hence, we cannot use 53 joules per mole. Instead, what we can use is 52.6316, because we want to use the actual value to do further calculation, because if we use the approximate value, we're not going to be getting the actual value. So what we need to do is use the actual value, and then at the end of the calculation, then we can approximate the new value that we're going to get. You're going to see what I'll do in a second. So that will be 52.6316 joule per mole Kelvin minus 8.3145 joule per mole Kelvin. So you subtract this calculator. So you have Cv comma m to be 44.317 joule per mole Kelvin. So approximately Cv comma m is approximately 44 joule per mole Kelvin. So this is actually the value that we're going to approximate. And you may be confused that how do we get 44? Well, let's not forget our question. The smallest value that we're given in the question is a two sig fix. So we have to put our information and estimate or approximate to two sig fix, and we have 44 joules per mole Kelvin. So if you have any questions or suggestions, please put it in the comment section. If you would like me to tutor you, I tutor middle school, high school, and college level students, STEM related courses, and I tutor both person. I also do personal tutoring sessions as well as group tutoring sessions. So if you would want to book a session with me to see if it works for you, then make sure you email me at shahabitutoring@gmail.com, and email me fast, because I already have students and there's going to be a time I'm not going to be taking any more students. So if you would like to, yeah, if you would like to succeed and get an A in all your STEM related courses, I'm the tutor for you. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.